Let's determine if the specific value of a variable is a solution or not. The solution to a linear equation in one variable is not the process of reaching whatever we would like to achieve. The solution is actually the value of the variable that, when substituted to any linear equation or a specific linear equation in one variable, it could make the equation true. Looking at the first group of our activity here in this pre-break session, is to determine whether the given value for variable y for number 1, m for number 2, x for number 3, and p for number 4 could become or could actually satisfy the equation, and then later on decide whether they are a solution or not. Again, let me repeat, a solution is a value of a variable which can make the equation true. Let's try in number 1. In 2y minus 4 is equal to 10, we are to show if y is equal to 7 could make the equation true. To do that, we are going to apply one of the things that we have learned in the first chapter of this grading. By evaluating algebraic expressions, we are just simply going to substitute the value of the variable in the given equation. We have here 2, and instead of y, we will have 7. But do not forget that 2 and y is separated by multiplication. Hence, the operation here must still be multiplication. And with that, we will use parentheses. And minus 4 is equal to 10. Once that we have substituted the given value of the variable, we can actually place here question marks because we are not yet sure whether the equation is true or not. The thing here is this, please be guided with this one. Just by looking at the given expression after substituting the value of the variable, we can automatically say, hey, sir, yes, y equal to 7 is a solution to the equation 2y minus 4 equals to 10. Because so on and so forth, as you apply with the processes, it will be equal to 10. But that is not the goal. The goal here is to make sure that both sides of the equation are correct. Okay, so to do that, let's just simply continue with the process and yield with the same results to both sides. So we have here 2 times 7, application of MDAS. You will have 14. Sorry, let me still be using red. 14 minus 4, 10. Still, even if it's too obvious, let's just continue until both sides will be the same. 10 is minus 4 is, 14 minus 4 is 10. 10 on the other side. And once we reach this equation where both sides are the same, we can now use the check mark. That would tell us that we have reached that identity. And with this, once we have reached this, we can say that for y equal to 7, this is a solution. Let us use other colors, right? This is a solution to the equation in number 1. Let's proceed to number 2 and do the same tricks. We are going to apply the value of m, which is 2, to both sides of the equation here, since both sides of the equation rather have the variable m. To do that, they have here 5 times 2, the value of m, plus 2 equals, again, question mark, because we are not yet sure. And then we have 2 minus 8. Again, even if you are somehow seeing the result already, the goal here is to make sure that we have simplified everything. So 5 times 2 is 10 plus 2. Here on the other side, you have negative 6. Again, don't worry about that. Just simply continue. 10 plus 2 is 12. The other side is negative 6. And since both sides did not meet the same value, you use this one, not equal, and declare that the result for now, the value for m of number 2 is not a so sorry solution. Okay. Look at the difference between numbers 1 and 2. As we applied all necessary operations, we have reached an equality. But here, this is an example of an inequality since both sides of the equations do not have the same value and declare not a solution. With this in mind, let us continue with number 3 and number 4 as we have different values, uh, different equations now. So x is 10 for number 3. Let's proceed. You have 2 times 10 minus 3. We still have plus 1 here. And then question mark. Let me use this one, red. Okay. And the other side will have 10 plus 5. Notice that it's very important to look at the operations of separating all the terms so that you will be guided later. Let's continue. You will have here 2. 10 minus 3 is 7. And you have here plus 1. Is it equal to 15 as we add 10 and 5? Even if you will say yes, please continue. The goal is just to make sure that there are no other operations for either of the sides. 2 plus 7 is 14 plus 1. This may sound too obvious, but then again, the goal here is to practice so that we will be able to remember these steps here. And finally, 15, 14 plus 1. And you have here another 15. That's question mark. This would mean x is equal to 10 is a solution. To number 3. As for number 4, let's just do the same processes. You have 3, and the value for p is negative 2 plus 4. Is it the same as 2 times negative 2 plus 5? Question mark at this point. PEMDAS or GEMDAS allows us to add first, just like what happened in number 3, the terms inside the grouping symbol. And you will have 3. Negative 2 times, plus rather, 4 is positive 2. The other side will have 2 times negative 2 plus 5, which is positive 3. Question mark still, so that we will have our final step. 3 times 2 is 6, equal to 6. Both sides now have the same value, and you can now declare that in number 4, p is equals to negative 2 is a solution. So it's as simple as this. We are using now our evaluating of algebraic expressions with consideration to an equality or an equation. Mind you, this is very important as we proceed later to the solution set or the solving for the solution set of the next group of items. We need to have this process before declaring something else. This is how we determine whether a value of the variable is a solution or not. Good eye.